in the past I've given you these. Okay, so in the past I've given you these. I've always asked you to just accept this and accept this. So in this video we are going to prove this, and then from this we will then use this to prove this. Okay, so our aim here is to prove this, but in order to prove this, in order to prove that this equals this, we are going to consider this sequence here. Okay, so it's quite strange in that we are trying to prove this here, but yet we are considering a different sequence. We are considering this sequence here. Okay, so let's just consider this random sequence. Now, once you've got this here, if you put if you put k equals 1, put k equals 1 into here, and k equals 1. When k equals 1, it will give you this. Okay, so this is when k equals 1, and then increases by 1. So when k equals 2, it will then give you this. Okay, and this here will be when k equals 3, and then this here would be when k equals n. That's the last term, and then this here will be when k equals n minus 1, and so on. Okay, so this whole thing here will give us this summation here. Okay, but then let's visualize our blocks. It's a lot easier. So imagine this as being, well, you can remove all the brackets, because plus you can remove all the brackets, and then consider this as being one block, and then consider this as being one block, and this is one block here, and so on here. And then when you look at this sequence, it will in effect give you this sequence here. Okay, but the thing is, this one here will cancel out with this one here, and then this one here will cancel out with this one here, and as it turns out, this whole sequence, the terms will cancel each other out. If you look at this term here, this one here will cancel out with this one here. Okay, and this term here will actually cancel out with some previous with the previous term here. So this one here does get cancelled out. Okay, and then the thing is, all these will get cancelled out. The only thing, this 4 here will actually get cancelled out with something else later over here. Okay, so this 4 here will get cancelled out with something over here, and then this here will also get cancelled out with something over here. The thing is that they will all cancel each other out, except from this term and this one here. So when you consider this term here, so when you consider this thing here, they will all cancel each other out, and the only ones that will be left will be this one here and this one here. So this whole thing here, hang on. So this whole thing here really becomes this. Okay. So now tidy this up, and blah blah blah. It will then give you this. Okay. So a summary. We set out to prove we set out to prove this. Okay. But the thing is, in order to prove this equals blah blah blah, we consider this sequence here. But then this sequence here equals this thing here. Okay, so after all that, this thing here equals this thing here. But now this thing here equals this. But now we are going to use a different route to break this up. You see, somewhere in this thing here is this thing buried inside here. So we set out to prove this, but the thing is, somewhere in here is this thing buried somewhere in this thing here. We are going to now break this up and then extract this thing here, and then use and then set this to equal this, if you know what I mean. Just watch it, and then hopefully you will get it. Okay, so somewhere buried in this whole thing here is this thing here. So this thing here is somewhere buried in here. So we are going to break this up. Okay, but bear in mind that we've already established that this equals this. Okay, so let's break this up now. So hang on. So this thing here, you can break this up as, hang on. Let's go back one step. So somewhere buried in here is this thing here. Okay, but let's break this up. So now we're going to square this thing here. Square it. It will then give us this thing here. Okay, and then take this down here. Okay, well, what we're trying to do here is to break this up and then extract this, because somewhere in here it contains this. So we're going to break this up and then extract this within this thing here. Okay, so break this up. It will then give us this. Okay, and then these two will cancel each other out, giving us this. And then we can break up the summation here. So this thing becomes this thing here becomes this. And remember, this is a constant, and then if you sum up this, when you sum up a constant, this thing here is just simply n times 1. It's just n times whatever the constant, which happens to be n here. Okay, and then this is a constant. We can take it out here. That will then give us this. Okay. And then now you can see that we can later extract this. You see. Hang on. Going back to here, I said earlier we wanted to prove this here, and somewhere buried in here is this term here. So you see we were trying to extract this within this thing here. Okay. Well, anyway, let's start again. Square this thing. It will then give us this thing. And then blah blah blah, and then break it up, and then the 2 here is a constant. We can take it out here, okay, and then can you see this is what we want. This is what we wanted. We are going to try and isolate this. So hang on. So this here is a constant. Take it out. It will then take us to here. Now take away n from both sides. That will then give us this. Okay, because 2n, take away n, that will then give us 1n. Okay, and then divide both sides by 2. That will then isolate what we wanted. Okay, so after all that, this summation here equals this. Okay.